if you feel like the entire field of medicine is moving faster than you can scroll, you're not wrong.
Not at all.
We are talking about genuine transformative speed, and it's all powered by artificial intelligence.
Right.
You know, the scale of this was just perfectly captured by the Microsoft CEO, Satya Nadella. He said, we'll know the system is truly working when a pharma company uses AI to bring a new therapy to market in 1 year.
1 year instead of 12.
Instead of the traditional 12. That shift from a decade plus down to a single calendar year, I mean, that tells you everything you need to know about the velocity here.
That quote really does highlight the sheer power AI brings, not just to discovery, but to pure efficiency. For our deep dive today, we're actually taking the latest edition of the MedAI Capsule newsletter and turning it into an audio briefing.
So people can catch up on the move.
Exactly. The goal is to give you a shortcut, to dive deeper into the newest research, the big policy shifts, and startup innovation in health tech.
And the central tension in all of this, whether you're a clinician or a researcher, it all comes down to trust. We're handling these incredibly powerful technological black boxes, but we absolutely cannot just blindly accept their answers, not when a patient's life is on the line.
Exactly.
Yeah.
So our mission really starts by tackling that fundamental problem. How do we move an AI system from being this sort of mysterious oracle that just spits out an answer to a reliable, trusted, and crucially transparent clinical partner?
And that question lands us directly on the most critical concept for all of this, explainable AI, or XAI. Okay, let's unpack this. XAI is essentially the translator. It's the investigator. It shows us exactly how an AI model got to its answer.
It stops it from being that opaque black box.
Exactly, the one that clinicians are, understandably hesitant to rely on.
And that explainability is really the non-negotiable step before we see wide adoption in medicine.
So why is it so critical?
Well, a few reasons. First, clinical judgment has to remain paramount. XAI lets a clinician use their own expertise to quickly audit the AI's output.
To see if it even makes sense for this specific patient.
Right. Does the data it's pointing to actually line up? Second, it's fast becoming a legal and regulatory requirement. Regulators need to know the failure modes.
And there's a third thing, which I think gets overlooked in all the tech talk, and that's just clear communication with the patient.
Oh, absolutely.
You can't just tell a patient you're recommending a serious procedure because, well, the algorithm said so.
Precisely. XAI gives you the actual data points you need to translate the machine's logic into, human language.
So if we know we need it, how does XAI actually pull back the curtain on these huge, complex neural networks?
Well, the sources sort of break it down into three main categories.
Okay.
First, you've got visual methods. These are really intuitive, and they're crucial for things like radiology or pathology.
So we're talking about things like heat maps.
Exactly. Heat maps, attention maps. They literally highlight the exact pixels on an image the model used to make its diagnosis. It's like the AI is pointing right at the tumor.
Okay, so that's for images. What about for, say, electronic health records?
That's where you get into the data-driven methods.
Right.
And to put it simply, these tools show which numerical features, a specific lab value, a vital sign, push the prediction score higher or lower for that one patient.
So if a model predicts a high risk of sepsis, SHAP might show that a high lactate level contributed, say, 40% to that score.
That's a perfect example. It's a transparent breakdown of influence. And then the third type you see are logic methods. These are fascinating.
How so?
They try to simplify the whole thing down. They use rule extraction to turn a really complex model into a set of simple if-then rules that a human can audit almost instantly.
Okay, this is where it gets really interesting, though. This is the critical insight for any medical professional using these tools. You've emphasized that XAI provides clues about the model, not definitive biological truth.
Yes. This is the core limitation.
What's the danger of missing that distinction?
The danger is misinterpretation. These tools describe what the model noticed, not the underlying pathophysiology. So, for example, a tool might highlight a patient's room number as a huge predictor of infection.
The room number.
The room number. Now, that doesn't mean the room itself is the cause. It probably just means patients in that room are clustered there because they're the most critically ill.
Or they're all under one specific complex service.
Precisely. The feature is just a powerful stand-in for a confounding factor, or it's an artifact of the training data.
So a clinician might see that and waste time investigating the room's ventilation system.
Right. When really the AI just revealed something about their hospital's patient writing system.
Yeah.
You have to treat these explanations as clues about the model's internal logic, never as definitive medical truth about the patient. That still requires human interpretation.
Okay, so with that crucial caveat in mind, where are we actually seeing XAI push clinical practice forward? That brings us right to early detection research.
Hmm.
The sources spotlight a systematic review that's looking at XAI methods for speech-based detection of dementia and mild cognitive impairment, or MCI.
This is a perfect example of XAI being used to justify some really powerful performance. The review looked at 13 studies, and the metrics are strong. We're seeing models with an AUC somewhere between 0.76 and 0.94
And these models are diagnosing MCI just by listening to someone speak.
by finding patterns in their speech. Things like unusual pauses, subtle changes in speech rate, or even a reduced diversity in their vocabulary.
And XAI is showing which of those markers are driving the prediction.
Absolutely. SHAP is the most widely used for those patient-level explanations. But, and this is the frustrating part, the review found a huge gap.
Which is?
Clinical readiness is low.
But if the tech is performing that well, why is it lagging? Is it a tech failure or something else?
It seems to be the latter. It's
Why?
a failure of integration. The review found that very few of these studies actually involved practicing clinicians in the evaluation.
So they never asked a doctor, is this explanation actually useful to you?
Exactly. Or does this fit into your workflow? If the AI is amazing, but it adds 5 extra steps for a nurse, it's going to fail in the real world.
So the tech can diagnose, but the process for actually deploying it is lagging because we're not bridging that gap between the lab and the clinic.
That's the takeaway. This kind of explainable speech-based AI has incredible promise. It's low cost, it's scalable. But we're still a ways off from routine deployment until we start prioritizing clinician involvement.
And bridging that exact gap is what happens when tech moves from research into the startup space. So let's shift to the other end of the spectrum. Deployment challenges, especially in resource-limited settings. Let's talk about the industry spotlight. Vuha Med Data, an Indian AI healthcare startup founded in Hyderabad in 2022.
Their whole mission is focused on scaling access. They specialize in AI-powered digital pathology for early cancer screening, specifically cervical cancer.
And their product, AI, it automates the slide review process.
It automates that initial, high-volume, low-complexity review, which is often the biggest bottleneck in huge public health screening programs.
And they're targeting these resource-limited environments with what they call AI in a box. What does that actually look like?
It means they provide an integrated solution, hardware and software, that can handle the whole digital pathology workflow, often without needing massive IT infrastructure or even continuous internet.
So it makes it much more affordable and accessible.
Way more. It proves that AI isn't just a tool for big Western hospitals. It can be a vital infrastructure for global public health where you just don't have enough human specialists.
And beyond these really specialized diagnostics, we're also seeing AI just improve basic clinical efficiency and patient experience.
Oh, definitely. In terms of safety, for example, AI models are now being used to predict healthcare-associated infections, HAIs.
And they're good at it.
Often comparable or even superior to traditional manual methods. It frees up a ton of specialized staff time.
Then there's the communication side, which I have to say was maybe the most surprising finding in the newsletter.
The GPT-4 study.
Yeah. A blinded evaluation found that GPT-4's answers to real patient questions were rated as more accurate, useful, complete, and empathetic than responses from both specialists and general practitioners.
It's astonishing, isn't it?
It really is.
It just highlights that AI already has this immediate utility in patient outreach. If AI can handle that personalized, empathetic communication quickly, it means clinicians can focus their limited time on the really complex conversations.
Speaking of freeing up clinician time, maybe the biggest win for their daily experience is from ambient AI scribes.
Right, the A-Bridge study.
It found that in outpatient settings, using the scribe markedly reduced physician burnout and that relentless documentation burden.
And it happened fast. It improved their undivided attention to patients, and you could measure that effect within just 30 days.
That's a massive immediate win.
A huge win. And we also saw AI being used for training. An AI chatbot gave real-time feedback to mental health professionals to help them with their communication skills.
Okay, so this rapid integration means the policy and legal world has to catch up, and fast. We have to talk regulation and training.
The need for formal training is now a major institutional mandate. The new AMA policy is mandating standardized AI education across med school and continuing medical education.
And this isn't just about how to use the tools.
No, it's about safeguarding the workforce against threats. like deepfakes being used for fraudulent medical documents or just to spread misinformation. The institutions are pivoting now.
And on a legal side, we're seeing big shifts too. India's new Data Protection Act, the DPDP Act, is going to fundamentally change how healthcare data is handled.
Everything from patient consent and storage to how you can even use data for AI research and daily hospital operations. It's a total reshaping of the legal landscape for health tech.
What's fascinating is how these big policy changes are forcing entire specialties to kind of look in the mirror.
Yes, the newsletter highlighted a really provocative thought experiment suggesting specialties like anesthesiology have to radically reinvent themselves.
The idea being they can't just hope to retire before the change hits.
Exactly. The argument is if AI can handle a lot of the mechanical, vigilance-heavy tasks, the monitoring, the calculations, then the human anesthesiologist has to shift their focus to perioperative leadership, to becoming the holistic coordinator of care before, during, and after surgery, to maintaining that human presence. It's a challenge to every profession that assumes its current task list is permanent.
That's the reality check, isn't it? If AI masters the mechanics, the human specialist has to focus on complex decision-making, on leadership, on the bigger picture.
Correct. It demands a higher level of engagement from clinicians.
So, as we wrap up this deep dive, we've gone from the conceptual problem of the black box and the need for XAI, all the way to real use cases like dementia detection, cancer screening, and reducing burnout.
Mhm.
And the big theme seems to be that while the performance is often there, AI's potential is really being limited by the time it takes to prove trustworthiness and achieve that routine clinical integration.
And to just put a fine point on that conceptual challenge, the quiz we highlighted in the newsletter,
Mm.
the reason advanced AI is called a black box is that lack of internal interpretability. Right. Clinicians just can't see the complex patterns the model used to get to its output. And that's the roadblock XAI is trying to dismantle.
Exactly, which circles us all the way back to the human element. We saw that qualitative study with palliative care professionals. They were positive about AI's efficiency, but they all emphasized the absolute need to preserve human connection, to watch for bias, to build trust.
That was their non-negotiable.
It was. So if AI achieves all this incredible speed of therapy in a year, burnout reduced in a month, our final provocative question for you to think about is this. How do we make sure we leverage all that power without losing the essential, irreplaceable human element in the process of healing?
A profound challenge. It's going to define the next decade of medicine.
Indeed. We'll leave you with that thought. Thanks for joining us for this deep dive.